inequalities that we have. All right, the two types, the first one, and I'm going to kind of put them side by side. The first one are called ands, and the second one is or. I should take notes, please. Can you see that? Okay. Ands are going to be the overlap of two inequalities. And is going to be the overlap of two inequalities. All right, what the solution, this is the solution. The solution means all values for the variable that make both inequalities true. That's what the overlap means. And we're going to look at it. You guys looked at it a little bit from a graphing perspective in your notes. We'll do some more of that, obviously. But ands is the overlap. It's the values that make both of them true. All right. Ors are all values that make either inequality true. So it's all values that make either inequality true. All right, from a graphing perspective, and this is just going to be a very general graph, from a graphing perspective, and this is usually, all right, from a graphing perspective, we might have something, and I'm just going to do a very general, so we might have a solution that's like that, and a solution that's like that, and the and is where they overlap. So that's typically what an and looks like. We have one inequality solution going to the left, we have another inequality solution going to the right, and so from a graphing perspective, it's where they overlap. So this is what a graph of an and looks like. If we look at an or, we're going to focus on ands today, but I want you to be able to see the difference between them again. I know you did it with Khan Academy, but an or, we're going to have one going to the right, this is usually, and one going to the left with no overlap. This is usually what an or looks like. So for our solution, on this one, all my x's are that shaded area. Those are all the possible x's. In my ors, all my x's are either going to be that one or all my x's are going to be that one for shading. All right, so from a visual standpoint, that's what those mean. From a solution standpoint, an and's going to look like -2 is less than or equal to x, which is less than 5. That's what an and is going to look like for a solution, is something like that. I mean, that's not what I graphed necessarily, but that's what a solution would look like. An or solution might look like x is less than or equal to 1 or x is greater than 6. That's what an or solution would look like. So you can see from a solution standpoint what it would look like with a variable. You can see it from a graphing perspective and you can kind of compare them. So in an and, we have a minimum and we have a maximum that our x's could possibly be. On all my x values are in between the minimum and the maximum. In an OR, they're either going to be less than one of them or greater than the other. There's typically no overlap in an OR. So questions so far just from a general perspective between the two of them. All right, so let's talk about graphing these, and let's talk about solving them and graphing them. Chris, do you want to move up? Because you're squinting. Do you know that? Okay. Who needs to see what's up there? All right, let's talk about solving compound inequalities with ands. So let's solve and inequalities. So typically ands look like this. -4 is less than r minus 5, which is less than or equal to -1. So the characteristics of this are, first of all, we have less than symbols. That's the first thing. All right, the second thing is that we have a minimum value on the left. We have a maximum value on the right. And in the middle is our actual. That's where our math is. So this is an and. To solve this, we would solve this the same way we would if this was a single inequality. So if I blocked off that right side, how would you solve this inequality? How would I solve this inequality if I just block off that right side, Jacob? Yeah, I'm going to do A and the opposite there. Well, whatever that math is, I'm going to do it to all three sides. All right, so what we're going to do is we're going to solve by adding 5 to all three sides. So whatever you do to get rid of that, to start solving that middle part, you're doing to everything, all three sides. So I end up with 1 is less than r, which is less than or equal to 4. All right, when we take a look at our solution, all right, this has to be true. And what I mean by that is, first of all, these are always going to be less than symbols. That's the first thing. What I mean by has to be true is 1 has to be less than 4. Can you see this? 1 is less than r, which is less than 4. 1 has to be less than 4 here. If it wasn't, if all of a sudden you decided to flip the inequalities by mistake, and you got something like 1 is greater than r, which is greater than or equal to 4, is this true? Is 1 greater than 4? Is that a true statement? Troya? No, this is not true. So what that means is something went wrong. So you did something wrong. You did something wrong. Typically, what you did wrong is you flipped an inequality when you shouldn't have, or you forgot to flip an inequality, something. You dropped a sign somewhere, something. Your answer has to make sense. This has to be a true statement. 1 is less than 4. 1 is less than r, which is less than 4. All right, let's take a look at another one. Yes. Yes, you're going to be graphing these. So I'm just going to show you another one from a skills standpoint, and then we're going to graph it. All right, so I want to solve and graph. So I have negative 6 is less than or equal to 3x, which is less than 15. So what should I do to solve this? What should I do to solve this? Matthew? Excellent. I'm going to divide 3 on all 3 sides. So I get negative 2 is less than or equal to x, which is less than 5. Questions on solving it? All right, so now we're just going to graph it. So let me show you what I want you to do when you're graphing. First of all, always draw a number line. Seems like a weird thing to say, but I always have somebody on a test not draw the number line. All right, I need to put both of them on here, so I'm going to drop that 0 kind of to the left a little bit. What kind of dot's going to go on my negative 2? Brenda, or Colin? It's closed dot. All right, right now what I'm graphing is I'm graphing x is greater than 2, negative 2. So, Colin, if x is greater than negative 2, where's my shading for all my x's for this one? To the right, so I'm going to kind of do an arrow here to the right. All right, here's my 5, 1, 2, 3, 4, 5. All right, Serena, is it going to be an open dot or a closed dot at my 5? So now I'm graphing that second part to it. It's an open dot at 5. Here's my 5. Here's my negative 2. And then what are all my x's in relation to my 5? Serena, bigger or smaller? Smaller, so they're going that way, right? So our solution is where these overlap. So it's going to be between that minimum of negative 2 and that maximum of 5. And that's how I want you guys to show your graphing. You're showing them both individually graphed and then how they overlap. Yes. Yes. But I have to see very clearly both of those two graphs individually and then their overlap. Who needs to see what's up there? Questions on this before I have you guys do another one? Okay. All right, so I want you to solve and graph this. Is less than negative 3n plus 1, which is less than or equal to 19. All of you solve that, please. And graph it. Remember, you're following your inequality solving rules. All right, pay attention if you're in a situation where you've got to put inequality symbol. When you're done, your solution has to make sense. All right, you need to make sure that you have less than symbols when you're done, so you might have to rewrite your answer. All right, and then the minimum must be less than the maximum. All right, somebody help me out. What am I going to start doing first to start solving this? Jacob? Excellent. All 3 sides, right? Yep. So I'm adding negative 1 to all 3 sides. So I end with 9 is less than or equal to negative 3n, which is less than or equal to 18. Now what, Jacob? Excellent. Thank you. Yep, thank you for correcting that. Now what, Jacob? Yeah, you've got to flip that symbol because we divided by that negative 3. That's exactly right. That coefficient was a negative 3. All right? negative 6. All right, so what I want you guys to do is I want you guys to put this in the proper order. All right, we want it least to greatest. So you're just going to switch the order, making sure that you keep the smaller part of the inequality pointing the smaller way. So if I write this right, it's negative 6 is less than or equal to n, which is less than negative 3. So I just flipped it around with the same sides of the inequality facing the same, the numbers the right way. Somebody tell me now how to graph this. Well, first of all, is that true? Is negative 6 less than negative 3? Isabel? Yeah. If you had not flipped these, it would have been negative 3 is less than negative 6. Is negative 3 less than negative 6? No, so you knew you did something wrong. All right, somebody tell me how to graph this now. Nick, go ahead. So open dot at negative 3, and then which way am I graphing from negative 3? What are all my ends? Are my ends bigger than my negative 3 or smaller than my negative 3? So it's going to go to the left. So think about that as block off that negative 6 and see what happens, right? All right, and now my negative 6. What kind of dot goes on my negative 6? Close dot. And what are all my ends in relation to my negative 6? Are my ends bigger than my negative 6 or smaller than my negative 6? It's going to the right because they're bigger. And then my solution is in between those two numbers. It's the overlap. Because that's where the two graphs overlap, is in that space. Okay, now let's think about when you would ever use this. Okay, how many of you guys go to a public pool? Like a club, you belong to a club where you go to the pool, right? You go to swim club or, okay. So if you've ever gone to, how many of you guys have ever gone to a public pool where it's a swim club? Okay, they test the water to make sure that the pH level and the bacteria level are at certain levels, all right? So I want to use that. So this is our example, right? So the acidity of the water in a pool is considered normal if the average of three pH readings, is between 7.2 and 7.8 inclusive. That means that 7.8 and 7.2 are included in that. All right? If the first two readings are 7.0 and 7.9, what are the possible third reading values? All right, so this is a practical application. All right, if I take a look at this, the average of three readings is between 7.2 and 7.8. These are considered my maximum and minimum average. Max and min average. How many of you guys see that? You guys with me on that? Jack, you with me? All right, so if I set up like a game plan, I would have minimum average is less than or equal to my actual average, which is less than or equal to my maximum average. That is my game plan. So I have a minimum average, I have a maximum average, and then I have my actual average. Well, how do I find the average of 3 test readings? How do I find the average of 3 test readings? Come on, you guys, how do I find the average of 3 things? Ashton? I have them up and I divide by 3, so my first plus my second plus my third divided by 3 is going to be between my maximum and my minimum. So I started with a very general game plan, which I highly recommend. Your minimum of whatever you're measuring, your maximum whatever you're measuring, and then the actual. And in this actual is the formula to come up with that actual of whatever you're doing. Here it's the average of 3 test scores. All right, well, my minimum is 7.2 is less than or equal to, well, my actual is my first test was 7.0 plus 7.9 plus x, because I don't know my third one, divided by 3, which is less than or equal to 7.8. Now we're going to solve that. What do I have to do first to start solving this? What do I have to do first to start solving this? Jacob? Yeah, I've got to add those together. All right, so I'm going to do that for you. So that's going to be 14.9. So 7.2 is less than or equal to 14.9 plus x over 3, which is less than or equal to 7.8. Now what? Now what? Come on, you guys. We did this on a test. This same idea where we had an average and I needed to kind of find a missing value. What do I have to do next? What do I have to do next, Chris? Nope. No. What's this? What is this down here? Don't I need to get rid of that denominator? 3. I'm going to multiply everything by 3 to get rid of that denominator. So I want to get rid of that denominator because I need to get that numerator with the variable in it all by itself. All right, so 7.2 times 3 is going to give me 21.6 is less than or equal to 14.9 plus x, which is less than or equal to 23.4. All right, so I set up my average equation in between my minimum and my maximum. I simplified my numerator, and now I have to get rid of my denominator so I can get that numerator alone. Now what? Peter, now what? Excellent. Now I'm at a negative 14.9 to all 3 sides. So I end up with, my maximum is going to be 8.5. And my minimum is going to be 6.7. Those are my pH readings. All right, so I would say the third pH reading would be between 6.7 and 8.5 inclusive. Means it includes them both. So this is a practical application for and inequalities. You guys cool? All right, you guys can go. What you need to make sure you keep in mind is coming up with an equation in the middle for the actual maximum minimum of whatever it is that you're measuring. All right, you guys.